minus 40 seconds. Everything looks good for launch.
No planet beats Saturn for jaw-dropping beauty.
Saturn is the most photogenic planet in all the solar system. Some of the pictures are to die for.
But the postcards only tell part of the story.
Beauty's only skin deep. It really is roiling and seething inside.
Soar above the planet with its six-sided storms for ringside action.
I could just imagine what it might be like to hold a ring particle in my hand.
Even more mystery surrounds the impressive fountains of Enceladus, where the secrets of life might spring from the moon's salty geysers.
This is the little moon that has it all. And the samples are coming out in space. There's a big sign there, free samples, take one.
Then drop by the big orange moon Titan and descend beneath its smoggy veil.
I think it'd be, one of the seven wonders of the solar system.
Take to Titanian skies for a magical mystery tour.
The balloon just allows extraordinary possibilities for exploring Titan.
Drift over propane lakes, flammable sand dunes, and methane streams.
I mean, you could actually stand next to a babbling brook of liquid methane. I sometimes wonder, well, what would that sound like?
But nothing is as it seems here.
If you put your hand on a lava flow on Titan, you wouldn't burn your hand, you would freeze it.
All this and more, and only 1 billion miles from home. Ready to take off? There has never been a better time to venture where no human has gone before. To follow in the footsteps of our robot pioneers and explore the planets of our solar system.
Houston now controlling.
That's one small step for man. And 3 engines running normally, 3 to fuel cells.
Imagine boarding a flight to Saturn. What would you need to know before traveling?
Motor's gonna roll.
The best ringside vantage points, the must-see moons. Think of this as your personal guide to the splendor of the Saturnian system.
Oh man, that's incredible.
A wandering spot of light, twice as far as Jupiter, and 4 times further than the asteroid belt. Although it's 1 billion miles from home, Saturn has always commanded our attention.
Saturn is the most phenomenologically rich planetary system that we have in our solar system. Because of its rings and planet and magnetosphere and an enormous collection of very diverse moons, it has it all. I mean, even just taking the rings as an example, in Saturn's rings, we find examples of the other rings around Jupiter, around Uranus and Neptune. We find them in Saturn's rings. If you wanted to ask fundamental questions about the solar system in general, Saturn would be the place you would go.
When the Cassini-Huygens spacecraft took off in 1997 for a close encounter with Saturn, it was packed with essential items for a long adventure in deep space. A power generator, extra fuel, a good antenna, and a moon probe.
I figured once the data hit the ground, no one's going to want to be planning anymore. They want to look at the images, which is frankly how I feel.
Imaging team leader Carolyn Porco made sure it took along a pretty good camera, too.
He's actually made quite a task for himself.
After all, this destination is the pinup boy of the solar system.
Ben is right now.
Saturn might be the second largest planet in the solar system, but like gas giant neighbor Jupiter, It's a triumph of show over substance.
Well, Saturn is, first of all, a big, giant gas ball. Actually, it's a big, giant ball of fluid, and the outer parts of it are gases, atmospheres. But as you go deeper, it gets hotter and hotter, and also gets more pressurized. And so as you get down deep enough, you start getting sort of fluid effects. It's very strange, bizarre physics going on that we don't fully understand.
Saturn is a big boy. But pound for pound, a cosmic lightweight. It's big enough to swallow 765 Earths. But as the least dense planet, it would float on water. Like Jupiter, this is a world with nowhere to stand. With no solid surface, it's hard to measure how long a day is. Though the cloud tops go around about every 11 hours. But it's what's up above, not down below, that will draw the crowds to Saturn.
If you were booking a tour for Saturn, the big ticket item, I think, would be see the rings of Saturn from X, wherever X happened to be.
The view of the rings from one of Saturn's moons would be spectacular. Up close, this glittering disk shines with the brilliance of trillions of ice fragments.
It's just hard to imagine anything more beautiful than the ring system. They're the first thing that any kid with a telescope wants to look at.
Spotting these rings from a backyard telescope is a treat. In an instant, they can all but disappear when Saturn tilts toward the sun.
The overwhelming thing that you as a space tourist would be struck by is how incredibly thin they are.
They're no thicker than about 1 or 2 stories in a modern-day building.
It's much thinner compared to its width than a sheet of paper, for instance.
Interested in seeing for yourself? Strap in, space travelers. It's quite a ride.
Roger, roll, Atlantis.
After 7 years and 1 billion miles of space, the Cassini-Huygens spacecraft faces its greatest challenge on June 30th, 2004. To go into orbit. First, it had to maneuver through an obstacle course of rings.
The hopes and dreams of thousands of scientists and engineers are resting on the next few moments.
We've been to Saturn twice before with the Voyager 1 and Voyager 2 spacecraft, but rather than these quick Kodak moments, we wanted to take a nice, long, leisurely look at the Saturnian system. The only way to do that was to slow down and let Saturn's gravity capture us into orbit.
Current speed of the Cassini spacecraft, 50,000 miles an hour, and increasing as Saturn's gravity draws us in.
Cassini presses on, aiming for the gap between the outer F and G rings, hopefully clear of orbital debris.
There is always a risk if we hit something too big in a very sensitive area, like perhaps one of the computers or even the fuel tank, that perhaps we might have ended the mission very early.
We turned the main high-gain antenna in the direction that the craft would see the ring particles coming toward it so that it would act as a shield.
You are listening to the actual recording of tiny particles hitting the spacecraft as it crosses the plane of the rings.
Let's go ahead and switch Canberra over to B0.
So far, so good. But as Cassini disappears into radio silence behind Saturn, everything rests on the spacecraft firing its engine perfectly and slowing down. It's a nail-biting wait at mission control.
Go ahead and switch on.
The Doppler has flattened out.
As Cassini emerges proudly from Saturn's shadow, it turns to cross the ring plane again.
To any potential inhabitants of the Saturnian system, your eyes are not deceiving you tonight. There is a 30-second moon gracing your night skies, and that is the Cassini-Huygens spacecraft.
With Saturn's 62 known moons, Cassini finds itself in good company. With out-of-this-world photo opportunities to make even a seasoned professional gasp.
Saturn is the most photogenic planet in all the solar system, so you couldn't get luckier than me, right? The ones that give me shivers are Saturn with the rings, where Saturn is a crescent. We're looking down on the rings from above, and there's a moon in the background. They are just artistic compositions. Here I am leading a team of scientists. Our duty, our job is to take images, and we have this fantastic target. Kind of have this feeling like I'm standing on the bridge looking out the window. I have a very strong feeling of being at the forefront, being out there exploring myself. That's the thrill of it for me.
The view from Cassini's bridge exceeds anything seen before.
Lo and behold, as we got close enough, it looked like the rings dissolved into all of these, individual ringlets looking a lot like grooves on a phonograph record for people who remember phonograph records. And it was just very exciting then to try and figure out what could be causing that structure. What looked like rather featureless rings in a telescope now had, thousands of features in them.
I was surprised at how surprised I was at the clarity of the images, because I thought to myself, well, for Pete's sake, I've been thinking about this for years. For 14 years I've been thinking about this. I've been planning these images for a decade or whatever it was. You'd think I would have, anticipated, well, we're going to have this kind of resolution, it's going to look like this, and I just hadn't.
For the first time, vivid details of Saturn's rings are revealed, beckoning us to stare in wonder for a closer inspection. Everyone is familiar with the rings of Saturn. But what would you highlight if it were you sending back the postcards? Every tour itinerary has one main attraction. With Saturn, you just can't miss the rings. As imaging team leader for Cassini, Carolyn Porco has had a ringside seat.
The rings consist of just countless particles, and they range from big boulders the size of small apartment buildings, all the way down to the finest dust particle and everything in between. And they're all orbiting like crazy around Saturn at 20 to 40,000 miles per hour, but it's like traffic on a highway. Everybody can be going 90 miles an hour, but relative to each other, they're going very slowly. If you could put a spacecraft there and you could manage to move at the same speed, then the speed wouldn't be that dangerous at all.
You can think of rush hour on a Friday night, on the freeway, that the B ring has a lot of traffic and a lot of particles, whereas you go to the A ring, it's a little bit better. The C ring is more like being out in the country. You aren't going to see ring particles too often.
Possibly the remnants of a failed moon. The ring particles have been flattened by gravitational forces into a super thin disk, nearly 200,000 miles across. Edge to edge, that's almost the distance from the Earth to the moon.
I have, in fact, imagined myself orbiting Saturn, hovering over the rings. It's hard not to.
Oh, absolutely. You could go there and take your own pictures, create your own postcards, hi Mom, here I am at Saturn's rings, it's great. I could just imagine what it might be like to hold a ring particle in my hand and see, what does it look like? Is it like a fluffy snowball? If I start to pull it apart, what's it like on the inside? So, You can think of each of the rings, A, B, C, D, like different beaches. And so you'd want to collect samples from each of those rings.
And the icy grains on these Saturnian beaches are washed by passing traffic.
When a moon comes by, it creates a wake, just like a motorboat creates a wake that goes behind it. And I kind of imagine the ring particles doing an intricate cosmic dance around the planet, and can almost picture like little ballet dancers, each with their own orbits and paths, and sometimes colliding and encountering, and sometimes not.
Deeper secrets of this cosmic ballet are revealed, courtesy of a seasonal trick of the light. Once every 15 Earth years, as Saturn makes its slow trip around the sun, summer swaps hemispheres. In 2009, Cassini was in a perfect position to witness equinox on Saturn.
The sun at exact equinox will be shining exactly edge-on to the rings, but a little bit before and a little bit after, the sun will be low to the rings, just like the sun is now low over London. Any vertical protuberances, either up or down below the rings, will cast very long shadows. And we have in fact found that the rings aren't completely flat. There are places where the ring particles in fact form these structures that soar a mile or 2 or 3 above the plane of the rings. The first time in 400 years, we now know that the rings are three-dimensional.
Enormous and enormously complicated. The rings also form a major part of Saturn's amazing weather machine. Upon arrival, you might be slightly disappointed that the cloudy face of Saturn looks a little plain. But the planet beneath the rings is wild at heart.
You know, it's sort of like beauty's only skin deep. And on Saturn, as you get below the skin, you find, wow, this is a whole different personality to this planet than we've seen before. It really is roiling and seething inside.
Saturn's apparently peaceful appearance is due to a haze of high-level ammonia in the upper atmosphere. By looking deep into Saturn in the infrared, using the planet's own internal heat as a light source, Cassini has revealed the planet's true nature.
The winds on Saturn vary dramatically from the equator to the pole. In fact, at the equator, we have huge winds. We're getting close to 900 miles an hour now, near the speed of sound in that planet.
The winds are stronger at Saturn than they are on Jupiter, and that's a surprise because the two planets are rather similar in terms of basic composition. They're both gas giants. And yet Saturn has less sunlight to power the winds, and the winds are stronger.
Also surprising, twice as much heat comes from Saturn's hot interior than falls on it from the sun, a recipe for unsettled weather. Try explaining the six-sided vortex at the North Pole.
Saturn has a hexagon. It's some kind of a wave, but it's a permanent wave. It's been there since Voyager discovered it back in 1980. So this is just one more example of how atmospheric features, which are basically nothing but gas, they last forever on these giant planets.
There is another permanent storm at the South Pole. Not quite as strange, but gigantic in size. At 5,000 miles across, you could almost fit the whole Earth inside.
The South Pole has something that looks very much like a hurricane eye, except the clouds are 5 times the height of the eye wall around a terrestrial hurricane.
So it's kind of a window into the depths of Saturn, showing us just how dynamic the planet really is, and it's really kind of neat.
And at the bottom of this window, storms within the storm. Adding their own level of complexity to the weather forecasts of this alien planet are the rings. For half a Saturnian year, the rings block the light in the northern hemisphere, and the other half of the year, it's blocked in the southern hemisphere.
We are interested in studying seasonal changes on Saturn because of this extreme effect of the rings. Already we know that the sky was blue when the northern hemisphere came out of the ring shadow, and it's now turned sort of pinkish, yellowish, hazy color because somehow smog developed in the atmosphere of Saturn once the sun started shining. Probably not too different from smog in Earth's atmosphere, organic compounds or something.
For a planetary weatherman like Andy Ingersoll, Saturn has it all.
If I had an airplane that could fly in Saturn's atmosphere, I think it would be a wonderful sight to be surrounded by rings. It wouldn't get dark at night. There's more light on the night side of Saturn from the rings than there is from the full moon on Earth. So you could certainly read a newspaper on the night side of Saturn.
There'd be no shortage of strange stories to read by ring shine in the Saturn Express. And a lot of breaking galactic news. For Saturn is far from the only show in town. In case you haven't heard yet, the biggest story in the Saturn system is coming from the tiny moon Enceladus. It's shaping up as perhaps the hottest place in space to search for life.
T-minus 2 minutes and counting.
Shiny, white Enceladus. A bright ball hiding within Saturn's diffuse E-ring. This was a moon of little consequence until Cassini started sniffing around. But something was fishy here.
It was first found by the magnetometer team. They saw this hint of something in the magnetic field of Saturn wasn't just right. It was being kind of deflected to the side.
It was like unraveling a puzzle, and so the magnetometer team said, let's go closer. And as we got closer, we watched as a star went through and noticed the change in brightness. Something is going on.
We could see, even from a distance, there seemed to be this material coming off the South Pole. And it was so dramatic and so unusual that we thought, well, it might be a camera artifact.
Enceladus is tiny, just 300 miles across, too small for any kind of dramatic geology.
If you look at Enceladus, it kind of looks like it's covered in snow. It's very bright. It's as bright as freshly fallen snow.
Everywhere you look, there's fractures. There are mountain ranges and there are deep chasms. And when we finally looked at the South Pole, that's when it just became apparent. That's where all the activity is going on.
The team found something extraordinary. Row after row of enormous geysers shooting water and ice crystals out into space from the snowy white surface.
And so it was like a giant detective story, piece by piece putting the evidence together until finally you get back that really great picture, the smoking gun, showing the geysers actually coming out from the South Pole of Enceladus.
Water and water ice are spewing out of giant cracks from a region about the size of Southern California that's apparently just basically a big geothermal field. You can think of it that way.
It doesn't look much like California from orbit, just cool, as you'd expect an icy moon this far from the sun to be. But that's the mystery of Enceladus.
I mean, the bloody thing is hot. The South Pole is hot. Okay, it's like, it's as crazy as saying the North Pole of the Earth is hotter than the equator.
The best indication so far suggests the source of the water lies in a subterranean ocean or sea, hidden beneath the icy crust under the South Pole, warmed by tidal heating.
It's been a mystery because Enceladus is so small. It's not supposed to have that much heat. We think that heat source underground melts water, and that melted water, which might be mixed with some ammonia and other things to lower its melting point, then works its way out of the ground and spews up into space.
Here is the surprise entry in the search for life. This little moon that you'd expect to be pretty dead and dull, and coming out of the south pole of it is a jet of water ice. All the things you need for life are there. There's an energy source, there's a water source, there's an organic material source, there's a nitrogen source. Check, 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 check. All the requirements for life. This is the little moon that has it all. And the samples are coming out in space. There's a big sign there, free samples, take one. We just fly through and grab it on our way.
I think it is the go-to place in our solar system right now for investigating issues of astrobiological importance. It wins out the game over Mars, over Europa, over Titan even, simply because of accessibility. It's accessible. If these jets are deriving from liquid water, then they're there for the sampling.
The Cassini team has been flying the spacecraft at heights as low as 15 miles on its way to the plumes. Unbelievable precision flying for a remotely controlled robot that was never designed for such a feat, 1 billion miles from Earth.
From Cassini, we learned that there's methane in the plume, nitrogen in the plume, ammonia in the plume, organic molecules in the plume. It's a real soup. We're seeing a soup of organics being spewed out into space where it's freezing. You can almost go there and jar it, put it in a can, and sell it on Earth as organic nutrient soup.
On Earth, geysers and hot springs are home to bacteria with pedigrees dating back to the beginning of life. They can also be breathtaking. But nothing on Earth matches the Saturnian cold faithful.
Sitting there at the South Pole of Enceladus and taking a look at Saturn while you're sitting there watching this eruption going on would be beautiful.
It wouldn't be a dangerous thing. You would see these towering, dramatic fountains of just icy particles. We'd never see them stop because some of them actually extend tens of thousands of kilometers into the space above the South Pole and, in fact, into orbit around Saturn. This is how the E-ring of Saturn is formed.
Cassini has solved the mystery of how at least one of Saturn's rings formed. And this may help solve the bigger mystery of life beyond Earth.
I can't think of anything that would be more thrilling than to make that kind of discovery, that life has occurred not once, but twice in our solar system. And to know that it might be on Enceladus, which is a body that we have been exploring and that we have participated in this discovery it doesn't get much better than that.
T-minus 2 minutes and counting.
Enceladus may be the hottest ticket in town, but don't overlook the heavyweight contender for the title of Moon with the Most, Titan.
T-minus 40 seconds. Everything looks good for launch.
Larger than Mercury or Pluto, Saturn's Titan is the only other world apart from the Earth and Venus to have both solid ground and a thick atmosphere.
Titan, if it weren't in orbit around another planet, we'd have really no hesitation in calling it a planet in its own right.
We knew going that Titan was going to be exciting. Titan was a mystery hidden inside this hazy, smoggy atmosphere.
Cassini confirmed that Titan is shrouded in thick orange smog. Laboratory experiments have shown this could be the result of 4.5 billion years of sunlight reacting with the thick nitrogen and methane atmosphere. Cassini's camera could only see partly through the haze. The patches of light and dark looked like continents and oceans.
The picture we had of Titan before we got there was that it was going to be dark and eerie and cold. As dark as twilight is on the Earth, even at high noon, and you could be standing on a body the size of the Mediterranean, brimming with paint thinner.
For over 7 years, the European Huygens probe rode piggyback on the American Cassini spacecraft.
Give me an update by section only.
On Christmas Day 2004, it was sent on its way. Planet Earth never attempted to land on such a distant world before. With the Huygens probe on final approach to Titan, operations switched to European mission control.
The probe hurtled into Titan's atmosphere at 6 kilometers a second. The atmosphere would have been glowing violet around the probe as it decelerated.
Once on a parachute, the probe descended for the first 80 miles, seeing nothing but smog and haze.
As we got closer to the surface, down at about 30 kilometers, the surface features started to peek through the haze. Progressively, this landscape emerged of these bright hills cut by small dark channels that show that there had been rain there at some time in the past.
The signal was taking over an hour to reach Earth. No doubt, Huygens was sending postcards from the edge.
There were just 20 of us in the office area where the pictures were delivered. It was dark in Germany, it was the winter. It really felt like we were out there gazing at this alien world that was just at our doorstep.
The probe drifted further, snapping these remarkable images all the way down.
We all kind of saw, our backyard in Arizona or the French Riviera, wherever it was you were from, you sort of saw some aspect of Titan that looked familiar.
They were everything that our images from orbit were not, because you could see a dendritic drainage pattern that looked like a river system, just like a river system would appear on the Earth. Boy, that was heady. That was like, ooh, it was like Jules Verne come true. It was just spectacular.
Paychecks.
Huygens landed on Titan. It sent back these few hundred pictures until the batteries died and the probe froze solid.
The probe landed with a thud on basically a streambed, an area littered with rounded cobbles that showed that these little rocks or ice particles had been tumbled around in a stream at some point in the past.
The whole thing just was very chilling, not in the sense of temperature, but just in the sense of what we were looking at. It was very, very alien.
It's not a place where you want to just jump out there in your shoes and socks and shorts and t-shirts. It's roughly 200 degrees Fahrenheit colder than dry ice.
With a surface temperature this low, nothing is what it seems on Titan.
Titan is a world with liquids. The difference is the liquid is not water. The liquid is methane. Think of gasoline. It's a liquid like white gas.
So you've got rivers of methane flowing on the surface. Anybody who's looked out of an airplane window flying over deserts and things like this say, yeah, I sort of understand what's going on the surface there.
Because it's so cold, water behaves like rock does and methane behaves like water does, but everything's just sort of shifted along a scale of volatility.
How do you end up with a landscape that looks so much like home on a world that's so different? At NASA's Jet Propulsion Laboratory, researchers are trying to determine how raindrops of methane can carve a landscape built from water frozen as hard as granite. Raindrop by raindrop.
So it's like rain on Titan, and you can see that when a drop is falling onto the ice, it just gets into the ice. It just disappears in the ice. Just incredible how much methane can be stored in the ice.
Methane soaks into ice like water into the ground. And just like on Earth, any overflow will cut its path downhill.
Titan would be a wonderful place to visit. Stand next to a babbling brook of liquid methane running by your feet, and I sometimes wonder, well, what would that sound like?
In fact, as we took radar pictures of other parts of Titan, we found even wilder things in the northern polar areas. There are entire lakes or even seas that looks to all the world like you could go take a boat and go do jet skiing or something, right? Up and down these channels there.
Titan is the only other place in the solar system that we know liquids exist on the surface. So here you have vast reservoirs of liquid natural gas, and oh, by the way, we've thrown in some ethane, which is a slightly more complex hydrocarbon, and oh, by the way, there's some propane in there. Everybody knows what propane is, so use it in your backyard barbecue.
Cassini's radar spied lakes as big as inland seas, even bigger than Lake Superior.
Imagine standing on the shoreline of what to you looks like an ocean of liquid hydrocarbons. That's gotta be pretty special.
And if you think the lakes are weird, try the volcanoes.
We think the material that comes out of titanium volcanoes is a mixture of ammonia and water, which allows water to melt at a much lower temperature.
This is lava on Titan, a stinky mix of water and ammonia, molten at minus 150 degrees.
You can build anything from small cones to large mountains on Titan out of this stuff. If you were a visitor and you walked up and put your hand on a lava flow, you wouldn't burn your hand, you would freeze it.
In stark contrast to the cryovolcanoes and wet polar lakelands, bordering the equator are vast titanian deserts, covered in dunes.
I think it'd be one of the 7 wonders of the solar system. What you'd see is an almost unending sea of massive dunes, exactly the same size and scale of dunes that we see on Earth. Some areas where you see nothing but dunes for hundreds and hundreds of kilometers.
To make sense of what Cassini's radar sees, Ralph Lorenz makes the trek to the Australian outback. Not as far as Titan, but still a long way away.
One of the interesting things going on here in Australia is that there are linear dunes, which are the same kind of dunes we see on Titan.
You can go right up to a sand dune on Earth and dig in it, make a cross-section and see how the beds of sand particles line up to see how the thing formed under different wind regimes.
Comparing the pattern of dunes on both worlds can reveal the pattern of the wind on Titan. A clue to decoding the moon's complex cryogenic climate system. The byproduct of billions of years of production from the chemical smog factory in the upper atmosphere, the grains in Titan's dunes may literally fall from the sky. Like a rain of flash-frozen coffee grounds, they are swept by the wind into deep piles that cover 20% of the surface. And like a good coffee, these titanian dunes are dark and rich.
The dunes represent a massive inventory of organic material, hundreds of times larger than all the coal, for example, on the Earth.
You're not likely to be hauling this alien coal home. But the liquid hydrocarbons lapping on Titanian shorelines could be very useful for the return trip.
There's more, let's call it fossil fuel type energy than we actually have known reserves on the Earth by a factor perhaps of 10 or even 100.
That's a lot of gas in anyone's language. But something even more valuable might be found among the storehouse of organic molecules. The answer to life, the universe, and everything.
How do you go from such simple material like carbon and hydrogen and oxygen and nitrogen to something which asks questions about where it came from? That's a huge leap. And on Titan, there's a real good possibility that some of those really difficult to understand intermediate stages actually occurred. It hasn't gone to completion, at least we don't think it has, although there are some people who think that if we go to one of Titan's lakes, we will discover titanian bacteria that have figured out how to metabolize liquid methane.
Well, that's not a liquid that we, life forms on Earth like, but maybe a life form on Titan that grew up with liquid methane would be perfectly comfortable there and would look at shock at the thought that organisms would live in water. Oh my God, those things on Earth living in water. Pity those poor Earthlings. We live in liquid methane, much more pleasant.
Titan is the ultimate test for life in our solar system. If life exists under these alien conditions, then you might find it anywhere. The Huygens mission will not be our only trip to Titan, nor Cassini our last visit to Saturn. These are just bold first steps on a journey that's just begun. Even before the mission is over, Cassini has left a thirst for a return trip. Planetary explorer Jonathan Lunine and aeronautical pioneer Julian Knott think they know the perfect way to do it. A robotic hot air balloon.
So what we're flying over now is very much like the Huygens landing site. And I'd love to see those ravines on Titan, those steep valleys where the methane is flowing and carving out the hills, very much like what we're seeing now.
The dream is to return to Titan and drop a robotic balloon into the atmosphere. A radioisotope generator will provide the electrical power and the waste heat to give the balloon lift in the chilly atmosphere.
Titan has a dense atmosphere, it's cold, the gravity is low, the winds are gentle, so ballooning is very easy.
The conditions on Titan are 1,000 times better than anywhere else in the solar system to fly balloons. It is the ultimate destination for balloons. I think this flight just makes the point so beautifully why a balloon is a wonderful way to explore Titan. If you're over an interesting area, it's very easy to come down, maybe even land on the surface, lower instruments down.
One could cover with a robotic hot air balloon the entire circumference of Titan in a space of perhaps 6 months.
You shouldn't think of Titan as a place just for robots. With a thick protective atmosphere and plenty of frozen water, Titan could be a more user-friendly destination for Earthlings than Mars.
When humans do finally move out into the solar system, and I think they will, Titan will be seen as a somewhat distant but very attractive place to go play. You don't need a pressure suit on Titan. You don't have that feeling, as the astronauts describe it, of trying to work with a beach ball between your arms.
Breathing from a souped-up scuba unit and outfitted in a cross between a super ski suit and a hazmat coverall, future Titanauts could explore with confidence.
You just need that thermal protection and oxygen, and then you can go play on the surface and take a balloon ride. It'll be a place where people will want to go to see a truly exotic and alien world.
Not even a minor rip in the suit will be life-threatening.
I did a calculation once of whether the small amounts of carbon monoxide in Titan's atmosphere would kill you before the hydrogen cyanide did. Actually, it turns out both are probably only enough to give you a headache, but the place would probably smell like an oil refinery.
Speaking of refineries, refueling for the return trip could be as simple as pulling up to the nearest lake to fill up your methane rocket, now under test development on Earth. And if you reach as far as Titan, why not a side trip to Enceladus as well?
The real question is not, does Enceladus have organics? Well, we know the answer to that. Or does Enceladus have water? We know the answer to that. The question is are those organics biological in origin? So on Enceladus, we are many steps ahead of where we are in terms of Mars or Europa. We already know that there's organics. We already know where they are. We already know how to get them. It's time to bring them back to Earth and look at them and ask the next level of questions. Are they biological?
It may not happen for a very long time, but I really think that's a must-do for us in taking the next step. And to me, the question of whether or not life has gotten started elsewhere in the solar system is the reason why we do this. You know, because we want, finally, ultimately, we want to come to understand why the Earth has been the successful abode of life that it has become.
Moving now into the extended mission. The Cassini team met recently in London to take stock of where they'd been and to plan the road ahead. It was the 58th time they'd met, and fitting that they chose the Royal Observatory in Greenwich to celebrate. The prime meridian here is the longitude, the mark on the ground, from which all great voyages are measured.
We have taken something that is so far beyond human reach, it's almost unimaginable, and we have brought it home.
This is the view back to our remarkable home planet that the first human out here can look forward to. A distant blue dot lost in the beauty of Saturn's backlit rings. It's a real image, another perfect postcard from Cassini, urging us into the heavens.
Humans have looked out from the shores of seas and oceans and imagined great adventures. Now think about standing on the shore of an alien sea, and we know those shores are there. We just have to go experience it, and that's what I'd like to do. I'd like to go land in a balloon, step out, pick up one of those rounded pebbles, and toss it at Huygens.
I've proposed that maybe we have to talk about a planetary park down the road, and where should we preserve for future generations? You know, do we want to go in and mine Titan for its methane? Maybe we'll go mess up other places, perhaps, but Saturn is just an exquisite place, and we should probably leave that alone.
With so many interesting moons in its flight path, NASA is making plans for what to do when Cassini's mission comes to an end, around 2017.
We want to make sure that the spacecraft doesn't hit one of these bodies, and so what we're going to do is put it into the atmosphere of Saturn.
Crash it into Saturn and burn it in a blaze of glory after a rich 20 years of exploration in space.
All the molecules that currently make up the Cassini spacecraft would still be at Saturn, and in fact will be there forever.
A fitting, fiery funeral for one of the greatest interplanetary voyagers of all time. It might be a ball of gas and float in water, but Saturn is a very solid destination, both for science and for viewing spectacular sights. We've only begun to realize the riches it offers, and only because we sent a spacecraft to stay. It's the same story everywhere in the solar system. You'll never know what you're missing if you never go.